Okay, so this time we have a base of 1/2. That base is caught in between 0 and 1. That's a b for base. So we know we're going to have a logarithm that is going to graph as a decay. Let's test it out. Again, log is base answer, and that equals an exponent. So if exponential is bia, we're going to bia bay, keep going back and forth from each form. Well, if this is log, the base is 1/2, the answer is x, and the exponent is y. When you convert it, the base is still 1/2. The exponent, the e spot, the exponent spot, is to the y, and that equals the answer, and the answer spot is x. That's where that came from. So I'm going to fill out that table. And we're going to see the decay start to form. Okay, again, I don't know why I set up the x's. It's okay to work it backwards, but honestly, with logarithms, it would be easier to pick y's, simple y's, plug them in, and see what happens. So for example, how I would do that, let's say y is 0. So when y is 0, what is x? Well, x equals 1/2 to the y. When the exponent is 0, the answer is 1. So that would be the ordered pair 1, 0. Now if I'm picking x's, I have to kind of work it backwards. If x is 1, I got to think, okay, 1/2 to the what would give me 1? Well, when the exponent is 0, the answer is 1. Either way, I still get 1, 0, and that is just fine. That's great. I need you to figure out if you think it's easier to pick y's and plug them in this way, or pick x's and plug them in and do it that way. Doesn't really matter to me. So for some reason I chose x's, probably because with functions we always usually input in our x's and output our y's. It just happened to be weird this time. So let's see, 1/2 to the y equals 2. Well, what is going to take a 1/2 and change it to a 2? A -1. 1/2 to the -1, that's 1 to the -1 over 2 to the -1, which you would then send across the line and change the sign, 2 to the first over 1 to the first. Now, if you had picked -1 for y and plugged it in here, you still would have ended up getting x is 2. So it doesn't matter either way you do it. Okay, let's do the 4. 1/2 to the what equals 4? -2. 1/2 to the -2nd equals 1 to the -2nd over 2 to the -2nd, that you would send across the line and change the sign, and have 2 squared over 1 squared, which is 4 over 1. Eight. Hopefully you're catching on. 1/2 to the what equals 8? -3. If you did it the other way, and you picked -3, 1/2 to the -3, that's a 3. That would be 1 to the -3 over 2 to the -3. You send them across the line, and you have 2 cubed over 1 cubed, which is 8 over 1. Okay. 1/2. 1/2 to the what, this is going to be an easy one, equals an x of 1/2. Well, nothing changed. So that would be to the first power. If you had plugged in a 1 for y in the first place, 1/2 to the y equals what? Clearly x is 1/2. I suppose I have been marking my points as I go, I'm sorry. So we've got 1, 0. We have 2, negative 1. We have 4, negative 2. 8, negative 3. And 1/2, positive 1, right around there. Do you see that you still have that asymptote? Whether it's a growth or a decay, the parent, when there's no shifts or stretches or shrinks, your parent, in this case, a base of 1/2, it's going to have an asymptote at 0 unless you change it left to right. From left to right, speaking of, we're going to connect our dots. And I'm a little off on that, but that's okay. Yeah, what else is new? So you see that decay. Hopefully you can tell that is decaying from left to right. Our domain is still dependent upon the vertical asymptote. In this case, it's the vertical asymptote to infinity. And our range will always be for logarithms, low to high on the y, all real numbers, negative to positive infinity. Now, keep in mind, if you make a shift, you would see left and right. It'd be in a parentheses, either adding or subtracting along with that x, inside with the x. So you would do the opposite of your instincts, and that would directly affect your domain, because that would be shifting the x equals 0 asymptote left or right, however many.